Let's do problem 8.65 of Sonntag. We have an insulated cylinder piston arrangement which contains R134 at an initial state of 1 megapascal and temperature of 50 degrees Celsius. So the initial volume at this configuration is equal to 100 liters, which is 110⁻³ meter cubed. R134 expands and the piston moves so that the state 2 has a pressure of 100 kilopascal. So the cylinder is insulated. Let's draw some insulation on this. The claim is that R134A does work 190 kilojoule against the piston, so the W is 190 kilojoule. So using the first law of thermodynamics, we straightforwardly have Q12 equal to U2 minus U1 plus W12. Now because the cylinder is insulated, U2 equal to U1 minus W12. So if you write this in terms of specific quantity, we have U2 is equal to U1 divided by the mass. The mass is known because at the state 1 we have the information required to find the mass, that is the pressure and temperature will give me the specific volume. Using the volume and the specific volume I can find the total mass. So this equation should give me the state property U2. Therefore with the help of U2 and the pressure I should be able to find out the properties of the next point. Is the process possible? Whether or not the process is possible is not deterministic using only the first law, because we have used the first law to find out the property U2. So the possibility cannot be judged using first law. So one must make use the second law. So because we know state 1 and 2, okay, so we know what state 1 and state 2 are, and we know that the cylinder is insulated. Therefore S2 minus S1 gives us an idea whether the process should be possible or not, because S2 minus S1 is equal to del Q, rather integral of 1 to 2 del Q by T plus delta S gen 1 2. Because it's an adiabatic cylinder, del Q by T is equal to 0. Therefore since delta S gen should always be greater than equal to 0, the sign of S2 minus S1 will indicate whether or not the claimed process of going from this state to this, of going from state 1 to state 2 with a work done of 190 is possible or not. Okay, that is the key. Okay, so let's do this problem 8.65. so volume equal to 100, is equal to, we want to avoid the use of the word volume because volume is a keyword in EES. So P1 is equal to 1000 kilopascal, T1 is equal to 50 degrees Celsius. Specific volume at 1 is equal to volume at R134A, T equal to T1, P equal to P1. Mass is equal to volume divided by the specific volume. Okay, so this gives us the mass. So U at point 2 is equal to U at point state 1 minus the work done divided by the mass. where it is given that the work done is equal to 190 kilojoule. The unit of work done is kilojoule, and it is consistent with the unit that we require EES to be in. So U is also in kilojoule. 190, this is in kilojoule, which is fine with inbuilt units. Okay. So that is the work done. But now we need to specify what U1 is equal to. That's very easy. U1 is equal to the int energy R134a at T equal to T1 and P equal to P1. Using this we should be able to find what U2 is. So U2 is found out to be 219.5 kilojoule. Now to judge the validity of the process, we must find out, so let us specify what the second process parameter at the state 2 is. So it is 100 kilopascal. So we must also find out the entropies. Because the change in entropy is an indication of whether or not the process is possible or not. So we have used the specific internal energy as one of the other properties apart from the pressure. Therefore, Sgen is equal to S2 minus S1. Now the sign of Sgen will indicate whether or not the process is possible or not. Okay, clearly Sgen is positive, thus indicating that the claimed process is possible. If the work done was something else, apart from 190 kilojoule, then the property U2 would have changed. If the U2 would have changed, the property S2 would also have been different. If the S2 is such that S2 minus S1 is less than 0, then clearly that particular process is not possible. This is how you judge whether or not a given process is possible or not.